Then there's the topic of regulation. I dread this topic the most because there are no regulations that apply to my situation. Creating new regulations can be a dreadfully slow process. Making changes to regulations can be even slower. This is a job for politicians. Only politicians can fix this. In this area, the politicians must step up to the plate and do their job. Each of these demo power plants will demonstrate safety for the regulators. However, new specific safety regulations will need to be drafted. First, approval to build these devices will be needed. Regulators must devise and perform an appropriate pre-startup safety checklist and inspection. Then, they must give a final approval for them to be turned on. The regulators must devise a list of desired safety benchmarks that must be met, both for these demo power plants and then later for the commercial fusion power plants. When you think about it, this is another one of my catch-22 problems. The regulators will not do any of this unless they are specifically commanded to do it via a law passed by the politicians. The new law must be specific and instruct the regulators to act swiftly. This is one of those situations where the energy companies and the venture capitalists will be closely watching. They'll be watching to see how the politicians play their hand. This is where I could get a lot of help from you. This is where I could get a lot of help from everybody. Over the years, I've talked with many people that have told me something like this. I really don't know. I really don't understand your physics well enough to comment on it. However, everybody can help when it comes to politics. The big picture, the vision, that is what is important. If you agree with that, then that is enough to help with the politics. I don't have a political action committee creating pro-fusion TV advertisements that pays for them to be aired at all hours of the day all over the country. I don't have a national pro-fusion energy group that has lobbyists in Washington, D.C. However, if you like my story, if you like my vision, then you might find I have you. When it comes to politics, that is more important than anything. These 3 demo fusion power plants will be built during the 3rd phase of my plans. They should produce more electricity than they use. At this time, nobody can predict their performance. Their overall performance cannot be predicted until engineering performance tests are performed on various components. If tests prove they work, then that will be historic. Finally, if they work or don't work, then what happens next? For example, if they're not quite as good as hoped for, then what? If they work, and if they can safely and economically make electricity, then can they be connected to the electrical grid in Minnesota? Who will be the utility operator? Who gets any profits? My laboratory? A utility? The state of Minnesota? United States Treasury? Potentially, if the demo plants are profitable, they could make a lot of money for a long time. So to recap, this was an overview of some of the more important aspects of my laboratory plans. However, there are 3 groups that still need more information. They are the venture capitalists, the owners and top executives at energy companies, and the politicians. Next, I'll go over the timeline of my plans a little bit more in depth. For venture capitalists, this might help them to decide how much work they need to put into this to be prepared. For owners and executives at energy companies, this might help them to decide what they need to do. For politicians, they need to see this information to make informed policy decisions on energy. This applies to state politicians as well as federal politicians. I've repeated my timeline here. Let's look at it. On the first line, notice how I have plans to build the lab in phases. I would like the state of Minnesota to fund a portion of the plan with a smaller grant. I skipped over the details in the 0 to 3 month section, so let me give a quick idea of what I'm thinking. During this time frame, I would purchase the land for the laboratory and would build a small, inexpensive, temporary office building. This temporary office building would have about 10 small offices, a lounge, restrooms, a conference room that is also set up for demonstrating basic physics experiments, heat, cooling water, and a large storage room for storing equipment purchases. This temporary office would be very basic. At this point, I would hire an office manager, a secretary, a personnel manager, a part-time accountant, a web designer, a 3D animator, a technician that can fabricate 3D models and experiments, possibly a publicist, and my own construction manager. I already personally know a number of people that I could hire for these positions. The personnel manager would start a search to fill key positions for the CEO, the engineering manager, and for the first physicists and engineers. At this point, I don't know exactly how long it will take to complete the construction of the main office. That is why I would start with a small, cheap, temporary office space. This is not going to happen, at least not quickly, without federal funding. With a Phase 1 federal grant, I could start working on these steps. The construction of the main office will start immediately on day 1, as soon as the land is purchased. However, it will take longer to build than the temporary office space. My goal is for a couple of the floors in the main office to be usable at 6 months, the ground floor and the top floor, and for all the floors to be completely finished at about 10 months. The office would have 6 floors, 4 above ground and 2 below ground. In these drawings of the lab site, I have color-coded the buildings. The blue buildings would be partially above ground and the yellow buildings would be completely below ground. My goal is for the central lab space to be finished in 6 months. It will be completely underground. It would be connected to the main office by an underground tunnel. The central lab would be a flexible lab space. Just about any experiment could be performed inside. Adjacent to the central lab space, there will be additional rooms for storage, a control room, a high voltage power supply, rooms for 2 large capacitor banks, a large impulse current system, lasers, an SES system, and the vacuum pump equipment. My goal is for these dedicated rooms to be finished in the 6 to 9 month time frame. I plan on building 3 demo power plants. In order, they will be Demo 1, Demo 2, and Demo 5. My goal is to have the 1 meter lab for Demo 1 completed sometime between 9 to 12 months. The 1 meter lab would be a dedicated lab space designed specifically to house Demo 1. The structure of the 1 meter lab would be funded by the Phase 1 grant. The experimental device, Demo 1, and its extra equipment that will go inside the 1 meter lab will be funded by the Phase 2 grant. In the 3 to 15 month time frame, my goals would include proof of physics experiments, proof of concept experiments, the fabrication of custom parts, and a variety of engineering tests. In the 6 to 10 month time frame, the laser ignition system must be started. In the 6 to 10 month time frame, the 1 meter cement trough and cooling system will be constructed in the central lab. In the 9 to 18 month time frame, I would build the 1 meter laser ignition system, perform test burns, fabricate the companion 1 meter confinement circuit, and retest burn times. Success with Phase 1 experiments would trigger a larger Phase 2 federal grant. This grant would then fund more expensive experiments in this phase. Somewhere between 12 to 16 months, 1 or more SES rings would need to be acquired. The Phase 2 grant would fund construction of the 2 and 5 meter labs. The 2 meter lab would house Demo 2 and the 5-meter lab would house Demo 5. The construction of the 2 and 5-meter labs would be funded with Phase 2 grant money. The experimental devices, Demo 2 and Demo 5, and their extra equipment that would go inside these labs would be funded by the Phase 3 grant. Construction for the 2-meter lab would go from about 9 to 15 months, and construction for the 5-meter lab would go from about 12 to about 18 months. In the 12 to 24 month time frame, tests involving the superconducting energy storage rings, the long duration burns, the transfer circuit, and the break-even device would be performed. In the 24 to 36 month time frame, the goal is to demonstrate commercial fusion power plants. 3 sizes will be tested, 1 meter, 2 meter, and 5 meter. The Phase 3 grant would fund Demo 1, Demo 2, and Demo 5. Each demo fusion power plant would have an expensive dedicated SES ring in its transfer circuit. Each of these fusion power plants should produce more electricity than is used. My goal for each is to exceed 2, 4, and 10 megawatts with continuous operation. It is possible their outputs could be much larger. It is possible the designs will have some poorly designed components that cannot handle the large pulses of electricity. Maybe high power switches or diodes will constantly be burning out. Maybe certain locations in the coils will be prone to shorting out. It is possible that continuous operation will confront a variety of engineering challenges. If successful, each demo power plant would be a complete small-scale working fusion power plant. If successful, each could be connected to the local power grid to provide electricity for the Twin City metro area. In terms of lab site construction, during this 3-year period, there would always be construction going on. Office spaces, labs, and experiments will all have separate construction timetables. My construction manager will face a challenging job keeping track of all of the details. It would be a mistake to not plan for the unknown. Therefore, the lab would be designed for at least one major expansion. There's something else missing from the drawings. Because this is Minnesota and winters can be cold, one perk would include indoor parking for the staff.